Welcome to the Explainer. So, today we're tackling a piece of tech that, let's be honest, often feels like a massive, confusing hurdle. But actually, it's literally the ultimate secret weapon for your math exams, the graphic display calculator. If you've ever stared at that intimidating grid of buttons and felt completely lost, hey, you are definitely not alone. But today, we're totally changing that. We're going to look at this device not just as a calculator, but as a seriously powerful piece of technology with specific levels to unlock. By the time we wrap up, you'll be wielding this thing with absolute confidence. Right off the bat, let's talk hardware. You might be holding a Casio, or maybe you're rocking a Texas Instruments device. Don't worry, we're definitely not picking sides in the great calculator wars today. While the exact buttons might look, a tiny bit different, the core graphing principles we're about to cover, they apply perfectly to both platforms. The logic is exactly the same, even if the keystrokes have some minor tweaks. So whichever team you're on, you're in the right place. Okay, let's dive right into this. We've got a structured map for the session, and we're going to master this beast in 4 clear stages. We'll kick things off with Level 1, plotting basics. Then we unlock Level 2, adjusting the viewing window. After that, we hit Level 3, decoding shapes. And finally, the ultimate goal, Level 4, extracting the data. This is exactly how we'll build up those calculator superpowers. All right, starting with Level 1, plotting basics. So this level is really all about taking a simple algebraic idea and telling your calculator to just make it visual. Think of a super simple linear function, right? Something like y equals 2x plus 3. When you punch that equation in correctly, boom, you get an instant visual confirmation, a perfect straight line right there on your screen. You've just translated algebra into geometry with a couple of button presses. Pretty simple, right? But what happens when the math gets way bigger than your screen? That brings us perfectly to Level 2, adjusting the viewing window. You see, your calculator screen is actually pretty small. It really only shows a highly restricted window of the infinite mathematical plane. And let's be real, staring at a completely blank screen during an exam is a very special kind of panic. To take absolute control of this window, we've got to speak the calculator's language. X-min is simply the absolute minimum value displayed on your horizontal x-axis. X-max is the maximum value, and X-scale, or X-scale, is just the distance between those little tick marks. And you know what? The exact same logic applies to the y-axis. Now, before you go making any manual adjustments, it is absolutely vital to know your starting point. The default settings usually range from -10 to +10 on both the x and y axes, and they typically have a scale of 1. So if your function's really interesting parts happen way out at, say, x equals 50, well, you are literally never going to see it on this default screen. So how exactly do we fix that terrifying blank screen? Well, you've got 3 main troubleshooting steps. First up, try the zoom facility. You can just zoom out to see the bigger picture or zoom in if you need fine detail. Second, use your directional keys to physically reposition or kind of pan the graph around. And third, if all else fails, just dive into the settings and change the scale manually by typing in entirely new X-min and X-max values. Remember, you are in total control of the view here. Moving right along to Level 3, decoding shapes. Okay, once your window is locked in, your calculator suddenly becomes this incredible tool for recognizing how different equations produce distinctly different curves. Just look at this visual contrast. On the left, we've got a classic quadratic equation producing that smooth U-shaped parabola. On the right, a cubic curve with its very distinct S shape. The shape alone instantly tells you the nature of the equation, letting you visually verify your algebra on the fly. And it totally works for simple lines too. Notice how a positive coefficient creates this upward slope, climbing steadily from left to right. Now contrast that with the downward slope created by a negative coefficient. You are directly, visibly connecting the numbers in the equation to the reality on the screen. It's like seeing the math come to life. And hey, don't worry about pushing the limits here. Take a look at this wonderfully complex graph showing multiple, really intricate curves overlapping all over the place. Your calculator can handle multiple functions at once without even breaking a sweat. This is absolutely crucial when you need to compare different equations simultaneously. All right, time for the main event, Level 4, extracting the data. We have officially arrived at the climax of our explainer. Because honestly, drawing the graph is just the very beginning. The real, undeniable power of a graphic display calculator is extracting incredibly precise data from that graph. Specifically, finding the exact coordinates where lines intersect the axes or where multiple lines crash into each other. That's how you solve those high-level exam problems. So let's walk through how to actually initiate this calculation, and we'll use a Texas Instruments layout as our example here. You'll first press the second button, that's usually located up near the top left, followed by the trace button. Because we hit that second key first, we're actually accessing the secondary calc, or calculate menu. And let me tell you, this is where the absolute magic lives. Once you're inside that menu, isolating an intersection point requires a highly logical step-by-step procedure. First, you just select intersect. The calculator is then going to ask you to confirm the first curve and the second curve. It does this just in case you've got like 3 or 4 lines on the screen. After that, it'll ask for bounds and a guess. So let's break down exactly what that means. To give the calculator its bounds, you use your directional pad. The system basically needs you to draw a virtual box around the intersection point. So you'll move the cursor to define a point just slightly to the left of where the lines cross. Boom, that's your left bound. Then you'll move it over to a point slightly to the right of the intersection, and there is your right bound. Finally, the calculator asks you for a guess. For this, you just move the cursor as close to the actual visual intersection as you possibly can. Then you press enter. And I mean really emphasize that press. Smashing enter solidifies your parameters and tells the calculator's processor to take over and do all the heavy lifting for you. Now, take a look at the final output right at the bottom of the screen. The calculator instantly displays the exact mathematical intersection. In this specific case, x equals 0 and y equals 37/5. Think about that for a second. You have completely bypassed pages of tedious, error-prone manual algebra to get a flawlessly precise answer in seconds. It's a total game changer. And keep in mind, this exact same logic applies to finding a zero as well. A zero is literally just fancy mathematical terminology for an x-intercept, the exact point where your function crosses the horizontal x-axis. You simply select 0 from the Calculate menu, set your left and right bounds around that intercept point, and let the calculator hand you the exact coordinates. So let's quickly summarize our core takeaways for today. You now possess a totally complete toolkit for mastering your graphic display calculator. You can swiftly input functions, you know exactly how to command that viewing window so you never get stuck staring at a blank screen, you can visually verify your equation shapes, and arguably most importantly, you know how to pinpoint exact intercepts and intersections to pull cold, hard data right off the screen. You are officially no longer just aimlessly mashing buttons. You are operating a high-level mathematical tool like a pro. So I'll leave you with this final thought as you prep for your next big test. Armed with these 4 levels of mastery, what complex math problem are you going to conquer next? Dive right in, practice these steps, and unlock your true potential. Thanks so much for joining me on this explainer, and keep learning.